Hello everyone, I am Basant Vikram Shahi and going to take mathematics for class 8. In our last class, we studied about area of plane figures part 1, in which we studied about rectangle, square and a triangle, and in this class we continue the same chapter 1, area of plane figures, in which we will study about some other figures. Area and perimeter of an equilateral triangle. This is a figure of an equilateral triangle ABC. Here AB equal to BC equal to AC. As all the sides are equal, so they are denoted by A here. AD is perpendicular, so height of the triangle denoted by H. Perpendicular drawn from the vertex to the base, bisect the base, means BD equal to DC. So BD and DC both are half of A, half of A, half of A. And if you see here, ABD is a right angled triangle. So according to Pythagoras theorem, P equal to is square root of H square minus B square. In the same way, AD equal to is square root of AB square minus BD square. AD perpendicular, AB hypotenuse and BD is base. AD is H, AB is A and BD is A by 2. So AB square A square, BD square A by 2 whole square, or H equal to square root of A square minus A square over 4. A square 2 square is 4, or H equal to square root of 4A square minus A square over 4. We have taken LCM here. If nothing is here below or under A square, that is 1. So 1 and 4 LCM is 4. So 4 A square, 4A square, A square, A square. 4A square minus A square is 3A square over 4. Therefore H equal to A by 2 root 3. A square root of A square is A, square root of 4 is 2, and as we don't get exact whole number value of root 3, so we write root 3 as root 3. Now area of equilateral triangle ABC. Here base is BC and height is AD. According to the concept of area of triangle, half into base into height. So half into base BC and height is AD. BC is A and AD is height that we have already obtained here as A by 2 root 3. So AD is A by 2 root 3. A into A square, 2 into 2, 4, and root 3 ones are root 3. Therefore area of equilateral triangle is root 3 by 4 A square. Now perimeter of an equilateral triangle. Perimeter is the sum of all sides. Here AB plus BC plus CA. So AB is A, BC is also A, and AC is also A. Therefore it is A plus A plus A, that is 3A. Area and perimeter of an isosceles triangle. This figure is of an isosceles triangle where AB and AC are equal. is denoted by B and BC is base denoted by A. AD is the perpendicular drawn from A to BC, so it is height of the triangle, and the perpendicular bisect the base, so BD and DC are equal and also half of BC, so half A, half of A. According to Pythagoras theorem, P equal to is square root of h square minus b square. Here AD is perpendicular, BD is base, and AB is hypotenuse. So AD is equal to square root of AB square minus BD square. Square root of AB square minus BD square. AD is H here. AB is B, so AB square B square. BD here is A by 2, so A by 2 whole square, or H equal to square root of B square is B square minus A by 2 whole square is A square. 2 square is 4. By taking LCM here, that is 4b square minus A square, 4 into B square, 4b square. Therefore, H equal to is half. Actually here we can get square root of 4 only, and in numerator there is 1, in denominator there is 4, so square root of 4 is 2. Half square root of 4b square minus A square. In the same way, now we take the area of isosceles triangle as we have taken the area of equilateral triangle. As this is also a triangle, so we use the same concept here also, half into base into height. So base B is here BC, height H is here AD, so half into base BC into height AD. BC is A, so half into A. AD is H, and H is here half square root of 4b square minus A square, so half square root of 4b square minus A square. 1 into 1, 1, A into 1 into 1, A, 2 into 2 is 4, and square root of 4b square minus A square is, as it is, square root of 4b square minus A square. And if we talk about the perimeter, according to the concept, the perimeter is the sum of all sides. Here A plus B, as these are 3 sides, so A plus B, A plus B is 2B. Now we talk about area of rhombus and perimeter of rhombus. This is a figure of rhombus where opposite sides AD parallel to BC, AB parallel to DC, and all sides are equal, denoted by here A, and the diagonals BC and AD bisect each other at right angle. Diagonals of rhombus bisect each other at right angle. Therefore, OA is perpendicular to BD and CO is also perpendicular to BD. Means AO perpendicular BD, because this is 90 degree, CO perpendicular to BD because these two angles are also 90 degree. And area of rhombus ABCD is area of triangle ABD, this triangle, plus area of triangle BCD, this triangle, area of triangle ABD and area of triangle BCD. The concept of area of triangle is half into base into height. So triangle ABD is half into base is BD and height is AO, and here for area of triangle BCD, base is BD and height is CO. So we have this formula. Now here half and half are common. We got common here. BD and BD are also common, so taken outside. Left here AO and here is CO. So AO plus CO. Half BD, AO plus CO. AO plus CO is AC. When we add this side and this side, means if we add AO and CO, we get AC. That is whole part axiom. So in the place of AO plus CO, we can write AC. Now the area of rhombus ABCD is BD is the first diagonal D1 and AC is another diagonal D2. You may write D1 here and D2 here, it doesn't matter. Now perimeter of rhombus, according to the concept, the perimeter is sum of all sides A plus A plus A plus A. Altogether there are 4 A's. A plus A plus A plus A, that is 4A. Therefore perimeter of rhombus is 4A. Now area and perimeter of trapezium. This is a figure of trapezium where AD is parallel to BC. In trapezium, one pair of parallel lines are there and other are not parallel. And here AE is perpendicular and it is height of the trapezium. The first parallel line is denoted by B1 and the second parallel line, hence BC, is denoted by B2. And area of trapezium ABCD is area of triangle ACD and plus area of triangle ABC. And the concept of area of triangle is half into base into height. So here in triangle ACD, this is the base and this one is the height. So half into base AD into height AE, half into base AD into height AE. And same thing applies here also in this triangle ABC. Base is BC and height is AE, so half into base BC and height AE. Now if we write the denoted letters here, it becomes half base AD is B1, B1 into height is height H, and here half BC is B2, half B2 into height is H, so it is H. And here half and half both are common, height H, height H are also common, and left B1 and B2, so we write them inside the bracket B1 plus B2. So this is the formula to find out the area of trapezium ABCD. And for perimeter of trapezium, we apply the same concept, sum of all sides AB plus BC plus CD plus AD. Now we see some solved problems here. Example number 5. Find the area of saddle region in the given figure. This is a figure. If you see here, if we produce FE to M, we find here rectangle and also rectangle here. So we can apply here the area of rectangle L into B, also here L into B. Here AB is 6 centimeter, BC is 10 centimeter, CD is 3 centimeter, and DE is 4 centimeter. Here AF is BC minus DE. Actually, AF plus ED together makes the length equal to BC. So if we subtract 4 centimeter from 10 centimeter, we are left with 6 centimeter here, and BM equal to AF, so AF will be 6 centimeter. 10 centimeter minus 4 centimeter equal to 6 centimeter. Now we have area of saddle region A, B, C, D, E, F is area of rectangle A, B, M, F, and area of rectangle M, C, D, E plus. Okay. Now area of rectangle is L into B. So AB is L into B is AF plus, and for this rectangle ED is L into CD is B. We take longer side as L. AB is longer side, so L. Here ED is longer than CD, so ED is L. Now L is 6 centimeter, and we got AF also 6 centimeter. ED L is 4 centimeter. CD B is 3 centimeter. So 3 centimeter. 6 into 6, 36. Centimeter into centimeter is a square centimeter. 4 into 3, 12. Centimeter into centimeter is a square centimeter. And 36 plus 12 is 48 square centimeter. Therefore, the area of saddle region A, B, C, D, E, F is 48 square centimeter. Now we will see another solved problem. Example number 6. Find area of the saddle region in the adjoining figure. This is a given provided in which A, B, C, D is a parallelogram with height AM, and this is an equilateral triangle having all sides equal and side is 2 centimeter. In solution section, first of all, here we write in triangle, equilateral triangle of PQR, PQ is denoted by A, that is 2 centimeter. In equilateral triangle, equal sides is denoted by A, that is 2 centimeter. And in parallelogram ABCD, base is BC, which is given as 10 centimeter, and height is AM, that is 4 centimeter. Now the first section of calculation, we find the area of triangle PQR. Area of equilateral triangle PQR, we denote it by A1, that is root 3 by 4A square. Area of equilateral triangle is root 3 by 4A square. So we apply the formula here. So it is root 3 by 4. A is 2 centimeter. So 2 centimeter whole square 2 centimeter whole square is 4 square centimeter. Here 4 and 4 cancelled. So we have square root of 3 square centimeter, and root 3 is 1.73, rounded into 2 decimal place. Secondly, we find the area of parallelogram ABCD, denoted by A2. Area of parallelogram is base into height, base BC and height AM. Base is 10 centimeter and height is 4 centimeter. 10 4 ja 40 square centimeter. Now we have got both the areas, area of parallelogram and also area of equilateral triangle. Now we subtract area of triangle from palm. So area of centered region is A2 minus A1. From A2 means from area of parallelogram, if we subtract area of triangle A1, we get this region, centered region. Okay. Now A2 is 40 square centimeter, A1 is 1.73 square centimeter. If we subtract it, we get 38.27 square centimeter. Therefore, area of centered region is 38.27 square centimeter. Our class is over today. All the students are suggested to consult their subject teacher for home assignment and maintain the work in fair copy. Thank you.